Welcome back to AI Talks with Chris and Nita, ready to dive into some more fascinating AI concepts.
Always. What are we exploring today?
Well, today's deep dive is into something called the Expectation Maximization Algorithm. We got some excerpts from a document titled Expectation Maximization Algorithm.pdf from a listener, and
Sounds a little technical.
it's been intimidating, right? But that's what we're here for, to break it down and make it clear for everyone.
Exactly. At its core, the EM algorithm is all about uncovering those hidden patterns in data, kind of like a detective piecing together clues to solve a mystery. It's especially useful when we're dealing with incomplete data. Like, imagine trying to solve a jigsaw puzzle, but some pieces are missing. That's where EM steps in to help us fill those gaps.
Okay, I like that analogy. So we've got this mystery to solve, and some pieces are missing.
Yeah.
And the document mentions these things called latent variables. What are those exactly?
Right, those latent variables, well, they're like the missing pieces of the puzzle. They represent those hidden factors that we can't directly observe but influence what we see in the data. Like, let's say a streaming service is trying to recommend movies you might enjoy. Latent variables could represent your taste in movies, even if you haven't explicitly told the system what you like. So things like your preference for certain genres or directors, those are all latent variables.
So the EM algorithm helps us figure out those hidden preferences, those latent variables, even if we don't have all the information. Makes sense. But then there's this term that keeps popping up, likelihood. What does likelihood mean in this context?
Well, likelihood is basically a measure of how well our assumptions about the data match what we actually observe. How well do our guesses for those missing pieces, those latent variables, fit with the data we have? Think of it like trying on different shoes. The shoe that fits your foot best, that's the one with the highest likelihood. And with EM, we're trying to find the shoe that best fits our data, or in other words, the set of parameters that has the highest likelihood.
So we're trying to find the best fit. Makes sense. But then there's this other term that's thrown around, log likelihood. Is that just a more complicated way of saying the same thing?
It's actually more of a mathematical tool, really. It's a way to make those calculations easier, especially when dealing with very, very small probabilities. You see, computers can have a bit of a hard time working with really tiny numbers, so log likelihood comes in and transforms those tiny probabilities into something a bit more manageable without actually changing the fundamental goal. It's like using a different type of ruler to measure the same piece of wood. The length stays the same.
Gotcha. So we're trying to find the best fit for our data. We're dealing with those missing pieces, those latent variables, and we're using this log likelihood thing to simplify the math behind it all. But how does the EM algorithm actually do all of that? What are the steps involved?
It's kind of like a back and forth process. You start with an initial guess about those latent variables, and then you refine that guess through two main steps, expectation and maximization. And these steps, they're repeated over and over, gradually improving our guess until we reach a solution that really fits the data well.
Okay, so walk me through those steps. What's actually happening during the expectation and maximization phases?
Sure. So in the expectation step, we use our current best to guess about the parameters to try to fill in those missing pieces of data, the latent variables. It's like using the parts of the puzzle we do have to make educated guesses about where the missing pieces might go. Like, imagine we're trying to restore a damaged photograph. We'd use what we know about faces and objects to fill in the missing or damaged parts.
I see. And what about the maximization step?
Well, in the maximization step, we take those filled-in data points, the ones from the expectation step, and we use them to refine our initial guess. So we're essentially saying, okay, given this completed picture, how can we tweak our assumptions, our parameters, to make the fit even better? It's like fine-tuning the position of those puzzle pieces we just placed, just making sure they align perfectly with the ones around them.
So we go back and forth between expectation and maximization, kind of like refining a sculpture with each pass.
Yeah.
And eventually we end up with a clearer picture, even though we started with some information missing.
Exactly. The power of the EM algorithm lies in its ability to handle those missing pieces, those uncertainties, And this is a big reason why it's used in so many different fields, from things like image recognition and natural language processing to even financial modeling and medical research. It's quite versatile.
That's really impressive. So the next time I'm listening to music recommended just for me, or reading about some new breakthrough in AI, I'll remember that the EM algorithm might be working behind the scenes, figuring things out, even when the full picture isn't completely clear. Thanks for breaking it down for us. This deep dive was really insightful.
You got it. It's always a pleasure to delve into these AI concepts.
And to all our listeners out there, thanks for joining us. Until next time.